students. Now we are going to discuss the third chapter of your chemistry, that is atoms and molecules. In this chapter we are going to discuss about the atoms and the molecules. What is meant by atom and what are the types of atoms are there, how they are going to combine to form a kind of element, a kind of a compound, or whatever it may be. Then nothing but what type of atoms and what are the laws and how the atoms are going to combine, and in the same fashion the molecules are also there. Here we are going to discuss completely with respect to the chemistry what about the atoms and the molecules. Now just look at the board what I have written here: the laws of chemical combination, the laws of constant proportion, the laws of conservation of the masses. Like that I have written here something over here, nothing but before going to this one, atom. And you know that you might be very familiar with the atoms and the molecules even more. Then atoms are nothing but the tiniest or the smallest particles of the substance. In other words, we are going to define atom. It is an indivisible particle of a substance. We can't further divide again and again. Okay, once the atom gets formed, that is a complete one. Atom is the smallest, it is the tiniest, and it is the indivisible particle of a substance. Here, with respect to atom, or by taking atom, what are the laws? Okay, what are the laws of combination, what are the laws of the proportion, what are the laws of the conservation of its masses? Like that we are going to discuss in this chapter. Now the very first one, the laws of chemical combination. The laws of chemical combination means how the atoms are going to combine to form an element, to form a compound, or to form a mixture, whatever it may be, how they are going to combine. Okay, in that we are going to study, we are going to take some kind of a laws. Okay, those two are the laws of constant proportions and the laws of conservation of the mass. And you might be very familiar with that, the laws of conservation of energy. And you know that the answer for that, energy can neither be created nor be destroyed, but it can be transferred from one form to the another. Nothing but it may take different forms of the energies. Here also you are going to define the same way the laws of conservation of mass. Nothing but mass can neither be created nor be destroyed. Now what is the meaning of this laws of conservation of mass? Once any two elements or any two substances undergoes a chemical reaction, okay, then is there any change in the mass, or else there is a change of mass can be seen in this type of reaction? Like that, so many questions will arise. The answer for those questions, there is no change in the mass, because already before going to the reactions, the chemical substance or any substance are present in a definite proportions by its mass. By its mass, there should be a constant proportion. For that reason, there is no change in the mass. For that reason, what we are going to define by taking this law of conservation of mass, nothing but mass can neither be created nor be destroyed in a chemical reaction or for a given chemical reaction. This is about your law of conservation of mass. Like that, nothing. This is very similar to the law of conservation of energy. Now the next one, the laws of constant proportions. So what I said that for a given chemical substance, the elements are present in a definite proportion by its masses. The law of constant proportion, for example, I am going to take for example this one, I am going to written here, you know that H2O, this is a chemical formula for representing the water molecule. To produce 1 mole of this H2O, to produce 1 mole of this water molecule, it needs a ratio called 1:8. I have written this one 1:8. What is this 1:8 then? 1 gram of hydrogen reacts with 8 grams of oxygen to produce 1 mole of water molecule, that is your H2O. To produce, I am going to written here 1 mole, and you know that the mole also here. To produce 1 mole of water molecule or H2O, it requires 1 gram of hydrogen to react with the 8 grams of oxygen. Then only we will get this 1 mole of H2O. Like that, you are going to take so many compounds or so many things to discuss or to confirm that what should be the proportion for a given chemical substance. Here also I am going to take, they have given one more example in your textbook. I am going to take this right now. NH3, you know that this NH3, ammonia. To produce 1 mole of ammonia, it needs 14:3. What it means again? I have written here 1:8. 1 gram of hydrogen reacts with 8 grams of oxygen to produce this water molecule. Again the same thing here also. To produce 1 mole of hydrogen, to produce 1 mole of hydrogen, 3 grams of hydrogen that should be reacts with the 14 grams of the nitrogen. I'll get your point. I am going to repeat again. 3 grams of hydrogen reacts with 14 grams of nitrogen to produce 1 mole of this ammonia molecule. Like that, we are going to take so many proportions, so many ratios to produce so many chemical combinations. It may be water, it may be ammonia, it may be sodium chloride. Whatever the examples you are going to take, you have to define in this fashion. And this we call it as law of constant proportions. Nothing but to produce a chemical substance, to produce some product. Okay. Then the given elements, the present element should be present in a constant, in a definite proportions by its masses. For that reason, what I have said that grams, we are going to express the masses. Okay, you take any examples to define the constant proportions. Then after all these things, then one more what I have written here, the Dalton's atomic theory. Dalton is a name of a scientist who has given some postulates, who has given some hypothesis, who has given some theory regarding atoms. Okay, with respect to atoms, he has given some postulates, and those postulates are that theory we call it as Dalton's atomic theory. I have written here Dalton's atomic theory. He gave these postulates, and just one by one we are going to discuss here. The very first one, the matter made up of tiny particles. You may take any solid matter, you may take liquid matter, you may take any gaseous matter. All matter should be made up of the atoms, and the atoms again nothing but the tiny particles. These tiny particles are nothing but your atoms. Okay, this is the first postulate. And the second one, atoms are indivisible particles. You can't further divide anymore. You are not going to divide the atoms. For that reason, what we are going to take, the atoms are indivisible particles. These are indivisible. Then the third postulate, what is that? The elements in any matter, they have identical masses and the chemical properties. Then what is the identical masses and the chemical properties here? For example, you take any element. For example, I am going to take the gold. I am going to write like this, capital A and the small u, AU. This indicates the gold. This is the chemical symbol for the gold. Here, for example, you are going to consider this gold, the masses. You take the atomic masses or the mass of any atom. Throughout the gold, throughout that substance, the mass are one and the same. What is that mass? That is an atomic mass. By taking the mass of any atom in the gold, you are You will get the same answer, because for a given element in any matter, it has the identical masses for an element. Again, it exhibits, it possesses same kind of the chemical properties. For example, you take a piece of a gold, you take a piece of a silver, whatever it may be, the chemical properties of the gold throughout that span, throughout that length, the whole geometry of the gold is one and the same. Like that, you may take the silver also, or any kind of the metals or the elements. Okay, you will get the same chemical properties, you will get the same masses, nothing but that is an identical masses. These things with respect to the element, for a single element, because atom possesses this property. This is your the third postulate. When we come to the fourth one, this is also some important one. The fourth one, what is that? Atoms combine in the ratios of a small whole numbers to produce a compound. For example, you take two different elements. Okay, those two different elements are going to combine to produce a new compound. Okay, for example, you take a sodium chloride, NaCl. The Na is an element and Cl is also an element. The combination of the sodium with chloride, that will forms a salt. That is the household salt, that we call it as a common salt. Chemically we are going to call it as by a name called sodium chloride. Okay, Na is an element and Cl is also an element. The combination of both Na and Cl results in sodium chloride. When we are going to take the ratios of the sodium chloride, in that sodium chloride, the masses of the sodium and chloride are going to combine to form that sodium chloride. When that occurs, the small whole numbers to form the compounds, nothing but very small number of atoms by its masses, they are going to combine. Only few atoms, not all the atoms, not all the sodium chloride, not all the chlorine atoms are going to form the sodium chloride. Only few, very few atoms of sodium, very few atoms of the chlorine, they are going to combine to form this sodium chloride. For that reason, what I have written here, small whole numbers. Small whole numbers, you know that whole numbers? Okay, start from 0 like that, 1, 2, 3, 4, 5 like that. Okay, very few numbers, they are going to combine to form a particular compound. This is a fourth postulate. The last one of this Dalton's atomic theory, the last and fifth one, the relative numbers and the kinds of atoms are constant. For example, you take the atomic number, atomic mass number, like that. We have one more relative number. Okay, again with respect to the masses only, the Dalton's has given this postulate. With respect to the relative number, that is an average atomic mass number. Keep it in mind, the relative number is nothing but average atomic mass number for a given element, for a given chemical substance, are the constant. They are constant. Like that, they are given some different postulates with respect to the atoms, and this we call it as Dalton's atomic theory. And that is about your these things. Okay, thank you.